at it. Now, I want to say, since I'm making this video, this whole thing with the chain rule is like the foundation of the old style tensor calculus or tensor analysis. And I just want to show, take about 2 minutes just to show you where this is used in tensor analysis and tensor calculus. So I am So in tensor calculus, we would write something like this. Let's say we had one coordinate system. We'll denote it by x alpha. This is not x to the alpha. This is an index here. But in tensor calculus, we have upstairs and downstairs indices. I don't want to go into that right now. This is like a contravariant index, and here would be a covariant index. But remember, this is just a coordinate. This is not something to the power. So we have one coordinate system, and then we have another coordinate system. I'll denote it by x prime alpha. Some books will denote it by x alpha prime, either way. So the chain rule sort of shows how you can transform what's called the gradient. Let's say we have something like the partial, we just did this, the partial with respect to x prime alpha. This is equal to, let me get another pen here. Using our chain rule, this is equal to the sum over beta of the partial of x. Well, okay, let's do it the way I did it before. We would say the partial with respect to x prime alpha, I'm sorry, partial with respect to x beta multiplied by the partial of x beta with respect to x prime alpha. This is, if you think of this sum, it's the exact same thing. We have two things here, the other coordinates, and then we have the constant thing here, partial with respect to x prime. I'm not taking this is just a number. I'm not taking the derivative of it. This will be a number at each point in space. And this is frequently written with the Einstein summation convention, where we leave out this sum thing, and we would just write this as, I'll write it in reversed order now. So you can sort of think of this as a, the summation is implicit. Whenever two indices are repeated, it's automatically summed. This was one of Einstein's great inventions called the Einstein summation convention, and it really makes everything easier. And this is what's called a transformation matrix. For the coordinate transformation from x to x prime. And it's linear. That's the whole thing of tensor analysis. Everything is linear. So you have, this is called like the gradient. And it happens to be something called the covariant vector. If you notice, the index is up here, but it's in the denominator, so effectively this is a down index. Up indexes would be called contravariant, down indices are covariant, and this is the transformation matrix. And the beautiful thing is that it's so easy to invert using these basic rules of partial derivatives. I'll just show you, if you take this equation, let's say you want to know what the partial of x beta is in terms of the partial of x prime alpha. It should be obvious what it is, but let's just do it systematically. So we multiply this equation on both sides by partial of x prime alpha with respect to x gamma times the partial with respect to x prime alpha. Now when we do this multiplication, because we have the same index, it's automatically a sum as well. This is equal to the partial of x prime alpha with respect to x gamma times the partial of x beta with respect to x prime alpha. This whole thing multiplied by the partial of x beta. Now, we have two things that are summed. Let's do this first. This is our usual chain rule. And so this ends up being equal to the partial of x beta with respect to x gamma times the partial with respect to x beta. But the partial of one coordinate with respect to another coordinate is just the Kronecker delta function. And then when we sum over beta, we basically set this index. So this is just the partial with respect to x gamma. So now you see, if we rewrite the indices, you know, I could relabel gamma as alpha. So I would have the partial with respect to x alpha is equal to, I'm going to make gamma alpha and then this is just a free index. Over here, I can change that to beta. So this is the transformation, the reverse of this. And if you notice, it's exactly the same as this, except we just changed prime to unprimed coordinates. So we're just renaming things. And that's really a lot of what tensor calculus is. It's just a chain rule. One book that really covers general relativity really well is by Anthony Z. It's called Einstein Gravity in a Nutshell. And it's for advanced undergraduates. And it really just makes over and over using the chain rule as showing how you formulate Einstein's general theory of relativity. I recommend that book. It starts at the very beginning and goes very slow, but we'll end up going to the most advanced parts of general relativity. So that's the end of this review video on the chain rule, and thank you very much. And if you want, you might want to catch those deep dive videos. Thank you very much.